Hey guys, welcome back. Pretty excited about this video. It's a two-parter and I'm showing a lot of machining, not all the machining, but quite a bit of it, so you'll enjoy that. And it's making something that I'm really sure nobody has ever taped or made before. So I hope you enjoy, and I'll explain what it's about and why I'm making it when I bring you here over to the bench. Always a problem, right? Problems after problems. Well, my wife and I were redoing our entire backyard from grass, fence, all that. The back fence is to a canyon, and it originally had a wrought iron between the 4x4 posts all the way down. You know, it went all the way down to the ground. Of course, the wife doesn't want that, so I spent months making, there's wood on the bottom in here, and the fence boards are in here, wood boards. And then there's a small section of wrought iron on the top of it. So the new problem is the other day there's paw prints from a raccoon all over this thing. So since the damage is on this side, he's coming in from the front yard, coming down the side of the house, climbing through here to go out. I need to stop this before he destroys everything, and I don't want to have to keep repainting the fence. If I chicken wired or something this off, I've just trapped him in my backyard, and he's going to find out a way to get out, destroying something. So my only choice is, I've seen YouTube videos of them making this noise thing that triggers with a tripwire, and it uses a shotgun shell in the primer, and they're loading it with all kinds of stuff. It's like, no, I don't want to kill him. I don't want to blow my backyard up. So what I figured is I'm just going to use the primer. I have a ton of different primers. This is one. We got probably 200 of them for shotgun shells, because I used to reload and target shoot. So, okay, I got a primer. Now, let me figure out what to do. And this took a long time to design, let me tell you. It is tricky. Be a nice skinny thing. I figured, okay, I got a nice scrap piece of 3/4 1144. That'll work. Looks like it's, a good size for this thing. So, and like anything, when I'm finished with the project, finished finalizing the print, everybody's welcome to it. I'll send it to you, no problem. My email address is at the end of every video. So I think I'm ready to go. I mean, it's a 1/4 inch firing pin. Turn this down because I did find a spring that should work. It's stiff enough to do it. So the spring slides on this guy. He's turned down to 200. The cap screws on 4mm, drops into the whole thing. I use a 5/16 end mill. Like anything with these prints, when you design it, you got to make sure you have the tooling to make it. And I do have a 12mm 1.75. I forgot what it was. I think it's 2.5. I don't have the tap for it, but I do have the die. So I'm looking for the tap. So I'm not sure what I want to do with the threads yet. What else? Okay, so then that drops in here. I got a 5/16 end mill. I can do this. Outside of the spring is 275, so everything should work. I can pull it back, compresses the spring. I was going to put a little groove in here for a pin, so it's sort of like a hair trigger thing, or whatever, and you just tie your string, nylon string on it, pulls it right out. So I think I'm ready to go. I'm going to examine this a little bit more, and then I'll start making this piece right here. And I think that's enough of material for the whole thing. And I can always, after this is made, and this is made, and this is screwed in, I can capture out here. and I can just take the whole thing down to whatever size I think looks good. Then I can spin it around and just finish this piece off or whatever. So it should be interesting. So let me study it a little bit more. And then I was thinking too, you can get an eye loop in here, screw it in one of the posts, and I can have it, you know, this way or vertical and pull it out, and I can spin this around so this pin is wherever I want. So that's a thought. And if this is 12 millimeter, that's a 12 millimeter nut. I don't know why I don't have a 12 millimeter bolt, but it looks like this would just, what am I thinking? Oh, just slip through this. So I might have to file this out slightly, or just take the threads down slightly, and then I can just screw this thing in between the two. So that's one thought. And I'll probably take my shotgun out because I need to see exactly what the firing pin looks like. It's domed. Every shell that I pulled out is domed. I was thinking, oh great, it's off center, but I found one that's on center. Very teeny little dent. So this must be a tougher material, that it didn't dent as much as that. This is a big divot here. So it looks like hopefully being on center is going to work with it. And I'm hoping the spring is strong enough. I can always put spacers in here if I have to increase the pressure. And the scary part is I got to figure out where the tip has to be here when I screw this on, because I don't want it to go off in my hand as my hand's over the end of it here screwing it on. So there's a couple things still more to figure out, but I know I can start at least with this and see how it comes out. So hopefully the light's pretty good. Well, I've already faced it off, center drilled it here. No, I don't. It's supposed to be a 1/4 inch. So this is one size under the 1/4 inch, because then I'll come back with a 1/4. Made my mark how deep to go on it, so we're set to go. And these are the drill hog bits, which, like I said, man, I just love these things. They just go right in beautifully. Looks like the tailstock's in good alignment. Put a little oil in there. Did I move something? No. Alright, put my oil brush up here. Probably should use the Tap Magic for steel for this, but I'm just using my regular mix. Goes in so easily, so I love this stuff. And that 1/4 inch is going to go in like nobody's business. So this is for the primer. Back out a bit. It's kind of low RPM. I don't really care or pay attention to RPMs that much. I just dial in what I think is going to work. Almost there. If I can see my black mark. Oil's covering it up. Alright, I gotta see where this mark is. Oh, here's my brush. Brush. Oh, it's right there. Okay. So how deep am I, huh? Oh, I got a little bit more to go, yeah. Boy, why is it so hard to see that mark? Reflections or light or something here, huh? Okay, that's definitely got to be it. Plenty deep. So, time to change it out to the 1/4 inch bit. I undo that, pull it back, clean it up a little bit, and get it out of there. The other thing I do, well, let me blow it off with air, is I'll show you in a second. Let's see if the primer is going to fit, and I don't think I'm going to ream it. With these lays, the tailstock is always usually on center vertically, but it's not on center from side to side, and it's a pain trying to get them adjusted. So I always set them up so that the cutting edge is vertical. That way the vertical will cut, and if it worked sideways and I'm off center, I'm going to start cutting to the side. This way it always winds up finding itself to center. But in this case, you can see the bit's not moving at all. So, oh, there it is. Well, it was fine. So, I'm pretty much doing alignment on this machine. There, that's to that. Well, let's see if the primer fits. Hopefully I don't have to ream this thing. And I don't know whether I need to really chamfer that edge or not. Blow this off. Put it back in the set. There's that, close it. Where is the primer? I need a paper towel here. Clean this thing up, huh? Yeah, it's oil all over the place. There, perfect. Clean that up. That's got junk still in the hole, huh? Yeah. Wee, nice. Okay, do you fit? Should. Yep, perfect fit. So I'm not going to mess with it any further from that. Next, hey, can't even get it out. There, I got it out. Next, I need to, I guess, turn this down for threading, but not thread it. Flip it around, start doing all the other side, because I got a lot of milling that I got to do. Okay, set up by the print, 440 thou in, saddle stops in place, power feeds engaged. Most of these tools are what you call a push. Means you're going that way, you're pushing the tool in. Not drag means you're coming out the other way. But I pretty much get the best finish doing a drag, so I always wind up doing a drag. So I gotta go and look up what the diameter I'm supposed to go to here. Sometimes I do engage it the other way and do a push job, but that kind of gets it in and around. An 1144 lugs and 5,000 feet depth of cut. So, okay, the interesting part is imperial threads give you the major diameter of the thread and the minor diameter. Metric only gives you pretty much the major, and then there's a table or a chart with how much thread engagement do you want. 75%, 50%, and then they give a percentage that you have to subtract off their major diameter for threads. So since this is 12 millimeter, I'm going to have to go look it up right on the print what the diameter is I'm supposed to be at the target. Well, turn down to 471 thou. Put some light on it here a bit. Did my thread relief in the back. I like these tools. These are micro 100s. What is this? This is an RC375 something, because I had to cut the back off. But they're impressive even going sideways at a huge depth. I think I went way deeper than I needed, but I just want to be safe. Now, chamfer it. And I'm not sure whether I want to do this threading with a die or that's not really much of an angle, huh? I'm more of an angle than that. There. Threading die, or do it by machine, set the gears up for it. That's a pretty good chamfer. Because, boy, looking at it is a 12 by 125. Those are some pretty mean threads. I think I'm going to try. Yeah, it's just going to have to be done by hand because that's a huge die. think I'm going to try doing it with the die and see how successful. Because I do have a 4-jaw here, which is going to hang on to it pretty good. But clean this up a bit. Oh, actually, I need to turn it around before I do that, because I want to hang on to this and no threads. But which way is which here on this die? Funnel starts on this side. Is that going to be tough or what? Boy, it does not want to start. I think I'm going to wind up threading it by machine. So I could clean that up. That's a pretty good finish for just that particular cutter. Where is... Oh, here we go. I like using 600 grit. Does a great job. Just for fun. Why not, huh? Look at that. It takes a lot off in a hurry, boy. Looking pretty good, huh? Yeah, it's looking like perfect. And it doesn't need to be because it's going to be thread, so who cares? Scotch-Brite. Using that as a gorgeous finish. Put a little oil on it, clean it up. Yeah, it's not too bad. Wow, what a nice finish, huh? Yeah. Oops. Didn't get down in that groove. So I guess now it's cut it off, turn it around, do the other side, because then I got to do the milling and stuff on it. Where is... There it is. So, pretty nice, huh? Boy, is that pretty nice looking. Wow. Oh, I didn't... I think I am going to chamfer this middle here. This guy. That way I know the primer's going to sit all the way down in there. Yeah. Oh, that's pretty good, yeah. That's plenty. Alright, so let me go get it cut off. I guess I will show some of this. Look at that, man. I love that saw. Wind band saw. Some junk's in here. Clean them up a little bit here. The finger, stick it in there. And I gotta be back a bit because I gotta be able to clear things. So that should be good right there. Alright. Love this chuck. Look at this. No visible run out. Alright, what do I want to do? I'm going to use this guy, my homemade guy. Drop him in there. Tilt him a bit. About that much. Tighten, tighten. Everybody's tight. Yeah, this should work. I just need to clean up the outside, then I guess I'll face it. And a little bit more speed than that. Oh, that's a lot more speed. Okay. Alright, did it? Oh, I can clean it up in one pass. Oh, yeah. And that's the greatest finish, but I'll have to sand it. Oh no, it's missing stuff. Okay. Dig it in some tooth bow, I guess, huh? I'll close. 1 tooth bow. Oh yeah, that's a nice finish now. I'll still wind up sanding it, but oh, it doesn't look like I cleaned it all the way back. Shoot. And it looks like there's a lip back close to the chuck. Hopefully this doesn't do anything. Yeah, no, it's not. Alright, get rid of that. There, I got rid of it. Alright, face it off now. Oh, don't need the feet on. Ow. I have it walking away from the part while I'm trying to do it, huh? Alright, what do I want to take? Here, 3,000's cut. Oh, the saw is pretty far off. I think it's usually crooked to about a 10. So I'm going to take 3 more. 1, 2, 3. And that looks like that did it. I've got some chatter in there, so this tool needs to be tilted more. Alright, there, that's enough to do a final cut, yeah. Perfect. And I probably should chamfer it too, huh? Yeah. Just a little bit. Tool's clean, and I need this guy, right? Nope, wrong one. This one. I just want to do a slight chamfer to it. Low RPM. I'm just going to walk this in by hand. Oops, further back than that, huh? Yeah. Alright. Perfect. Sand it off. 600, where are you? 600. Sure stuff gets loaded up fast, you know? Almost perfect. You can't see anything. Yeah. Perfect. Fine. That's got these scraps in there. Beautiful, huh? Yeah. A little oil. Yeah, look at the junk. Comes off of it. Yeah, I don't want to chamfer the inside because that's where it's going to seal down. So, there it is. Ready to... Oh, I got to drill it out. That's right. Here we go. Oh, wrong thing. Alright, so the other side was a 1/4 inch. So, we need to clean this machine up a little bit. This junk, and junk, and put the tailstock back in for a 1/4 inch guy, huh? Center drill it. Yeah, I gotta center drill it. All right, so I want this guy here, and same thing. Set the cutting flutes vertical. Is that, which way is that? There. Oh, there it is, right there, right. Okay, there, and lock, I gotta go forward, lock it down, there. Alright. Right on center, man. Beautiful, huh? Where is it? What's going on? Start cutting, would you? Am I locked? Yeah. I think it might be a dull piece, but yeah, it's cutting nicely. Right? Yeah, dead center, perfect. Okay. So, stick the 1/4 inch bit in here now. Yeah, I can just go full 1/4 because I'm going to have to widen this up more for, right, it's got to be, yeah, I got to go in with an end mill because I want it a lot bigger. So the 1/4 inch is going to just hit the hole on the other side, I hope. Should fall right in. Alright, let's see. Stick it in there. Vertical. Where are you? There you are, right there. there, and just lock it down. Whoa, somebody's way off here. Why? Somebody is way crooked. It's not the bit. Is it the tailstock? Didn't lock down right, huh? Hold it down, lock it hard. Now where are you gonna be? Perfect, yeah. Something just didn't get locked down straight. Get some oil in there. Oop, dropped the brush on the bench. I wonder how hot that gets. Even though it's drill hog, and if I fry this bit, they'll give me a new one for free. Lifetime warranty, love it. Yet to fry one, but I haven't used them that much, really. I wonder if you were in an industry, though, a regular shop, yeah, you'd be using them like crazy and it would pay off. Gotta love 1144, huh? And back it out. Gotta be getting hot. Gee, I'm not that deep at all here. I'm pretty deep, I guess. Yeah, I could go just with an end mill and widen this thing up, but I'd rather not. You know, center cutting end mill. Oh, it's about to go through and through. Okay, so I think I'm probably going to use a 3/8 end mill, so I need to set up for that. Boy, I hope this is right. 1/2 inch. It's removing a lot of material. Basically, I think this is a grizzly high-speed steel, but I want low RPM. Let's hopefully this does not walk around. That's quite a bit I'm taking off, huh? Yeah, but okay, well, it's working. Why the chatter? Why the chatter? I don't like that. Maybe a little more speed. See, cutting there, it's fine. Jeez, I don't like that. I don't like that at all. So, oh man, did it go way out? I can always reface it. No, but it's chattering like crazy. So, I gotta try a different 1/2 inch. This guy doesn't like it. Let me see what, I'm losing this. What other 1/2 inch do I have? Is this a 1/2? Yeah, that's a 1/2. What was this? Yeah, that's a 1/2 too. Let me stick this in there and see what happens. Try to get everybody as short as possible. Pull this back. Wow, that seems like that's a lot bigger, but that's a 1/2 inch. Is this guy gonna do any better? Is that on it? Yeah, that's the same size. Guy wants to do the same thing, so I'm gonna have to drill this out and then come in with this guy. It's not gonna remove that whole lot of material. Yeah, it's chattering on the outside edges for some reason. I could try just increasing the end mill sizes. Maybe I'll try that. So let me square around off camera. Okay, 3/8 is a lot nicer. Got it marked for depth. And it's kind of slow RPM, but it just goes right in and gives me the curls I need. There we go. Doing it at a pretty fast feed too, just to keep it cutting. I don't know whether it's the quality of the end mill that was chattering or what, but even one of those half-inch ones I had marked on the side of the counterbore because it was excellent for doing counterboring. And yet here I'm trying to do a counterbore and it's chattering like crazy. I'm gonna back it out, clean it up. Probably put some juice in there. Beautiful sidewalls, right? No, not the best, but oil. So I can probably bore it too to get the sidewalls somewhat clean, but almost at depth. Ooh, hey! That just messed up my surface. Well, I can always redo it too. Re-sand it, re-scotch brite it. Yeah, that was kind of loose. Oh well. Give it a little more RPM so it doesn't grab like that. Almost there. And there, at depth. So I could put the 1/2 inch back in there and see what it's going to do. I made a nice mess of that thing, huh? Oof, yeah, blow that off. Ugh, what a mess. Let's try the 1/2 inch again, see what it does. Take this out. Oh, I got junk everywhere here. Okay, get the collet away. 3/8, 1/2 inch. Yeah, what's written on the side of that one I was talking about? Yeah, it says counter, so I'm gonna try it. Especially since it's marked with tape for depth. This was the first one that just chattered like crazy. Alright, well, lock it down, let's see what it's gonna do, huh? It's kind of low RPM. Let's see if it wants to work this time, huh? Yep. Just keep going on that. Ooh, I can always, oh man, jeez, I gotta go to low here. There. Shoot. Almost seems like I think it's cutting off center, but hopefully not. Looks like something on the outside. Wow, it's a lot of material coming out of there. Curious to see what it looks like, but I don't think I should stop just to lubricate it. Just keep going in, huh? Man, that's pretty deep. It's gonna chatter when I finally hit the bottom, I think. No, it won't. Wow, that's pretty deep. That's pretty scary deep, huh? Okay. I think I'm gonna call it quits at that depth. Nothing too special about what I'm doing here, other than I can't see because I had to change the lighting for the camera. I'm just going in slowly. I'm in 75 thou. 660, 720, 720 RPM, and just plunging down. I'm going to do it in 4 places, so. Well, it just kind of looks good, you know? It's hard to do this and not get my arm in the way of the camera. I don't want to really just go straight in. I'd rather do this plunging technique. It gives me a nicer finish. Less chatter, everything. So I'm not sure. I think I'm going to go in at least 50% of whatever end mill this is. So I'm just going to do a bunch of this off camera. Boy, are there a lot of firsts in this video, in this making. Come on, get in there. Oh yeah, okay. Alright, that's tight. Center drill. Yeah, I had to release, well, first of all, the end mill that I was using, I was plunging, it was working fine, but for some reason I decided to just go in, broke loose, rotated the part, so I had to go to a bigger end mill to clean it up and salvage it. That was the first, but I used a gauge pin, 3/8 gauge pin and a 45 on the granite plate to set the angle here. And so that was the first, using the new gauge pin set, yay. Center drill works nice, super sharp. I think I have one bad center drill. Next time I stumble on it, I'm going to pull it to the side and look at it. Ow. Okay, so then drilling this out is pretty easy. And then you'll get to see the other first, which is a kick. Alright, release that, go in. So I might do bigger holes, I don't know. Once I've done all 4, I'll just take a look at it and see how it looks, you know. Hey, does that. Yeah, I need more speed because it jams. Catches at the very last second going through. There, got it through. Probably should have used the other chuck, but the key. This is the other first. First time I never thought. The fractional reamer. As it cleans that hole up nice, it looks beautiful inside, and I don't have to deburr anything. Ooh, forgot to unlock it. Get some speed on it so it doesn't catch. Put a magnifying glass out so I can see what I'm doing. And it just goes right in there beautifully. And through. Yeah, gorgeous hole. Gets rid of the burr on the outside, so I don't have to deburr the outside, which is difficult to do on the outside of a diameter. So that was the other first. This is great. I lost a paper towel to clean this up with. Yeah, there's no burr out there. And the hole looks beautiful. So using my vice stop to keep setting it. I've done 2 holes. Here's the 3rd one. So I'm not going to bore you with the whole sequence that you just saw. Well, here we are back at the bench. I think it came out pretty good. Sorry, I did do the threading on the lathe rather than a die. Came out nice, and I'm sorry I didn't show the threading, but threading, you really got to pay attention to what you're doing. At least I do. So it came out nice. What else to say? Oh yeah, I was thinking about taking an end mill, pretend that's the end mill, and just hitting right here at a slight angle, put a groove in there. And I may come back some point and do that. Makes it look, I think, a little bit more wicked, but that would be a tough setup. So I got to put the lathe, all the change gears back to power feed rather than threading. Time to do this guy. And I did realize that this bore here that I'm going to do. I could do it with a boring bar, but I figured I was just going to do an end mill. So I bought, yeah, Speed Tiger. I like them. Micro grain. This off Amazon? I can't remember now. Yeah, it probably was. They do carry it. So the end mill that I have, oh, it's still taped shut? Yeah, it is. The end mill that I have is the right flute size. I forgot what it was, but it's 3/8 shank. So I couldn't go all the way in, so I had to buy this guy, which is, what is this size, huh? Half and 5/16, yeah. 5/16 by 13/16? I don't know, whatever. It's the right one. Because what did I say? Oh yeah, 5/16. So this is a 5/16, and I should be able to go all the way down to the bottom. So I'll probably drill the center out for the 1/4 inch, then do that piece. And again, you know, I got to come back and do the math here and figure out where this pin's going to be, so that when I screw this on, it's not, you know, not there right now. Yeah, this is to scale. So you can see that pin is going to be in there. I'll be compressing the spring as I screw it in. So I'm probably going to have to come back out here, you know, with this further. Yeah, I don't know how that works. Okay, I'll figure it out. But okay, and yeah, for what it's worth, I got tired of going to the internet trying to figure out the metric gears that you need. So there, did a table. Anybody wants this, you're welcome to it. I'll send it to you. Here's the whole change gear thing off the side of the lathe for imperial threads, and here's all the change gears for metric threads. And this one was tested because I just did the 125. This one I've done before on the oil container, no spill container. I did a 14 threads per inch. I wonder if I should put TPI in here. Might make a mark. TPI. Same way with this one. So pitch, yeah, maybe change it from pitch to just TPI and TPI. Okay, so onward and upward.